just the design of the world is going to look very different once we start embedding these systems, and it will take time to kind of redesign, with drone delivery in mind, or with autonomous robots in a warehouse. So imagining what that world will look like is quite challenging to kind of put together the implications of what this means for our labor markets, for our road infrastructure, all of that. But ultimately, there are big changes coming, and we will, in some sense, have to redesign almost from the ground up how we design the world around us.
How's it, everybody? And welcome to another Singularity Metaverse meetup. This is our 8th meetup we've been doing so far, and we are really, really privileged and honored to have you all here today, where we're going to be discussing some incredible topics. We're going to be I'm thrilled to introduce our speaker, who's Aaron Frank. He's a faculty at Singularity University and one of the leading voices in exploring the intersection of exponential technologies and human transformation. And really today's session is around spatial computing for AR. How do we see these 3D simulations, how they're advancing AR mobility, robotics, and leading toward an era of intelligent machines, taking us right to the edge of what's next. And as we move towards a world where every machine that moves becomes autonomous, spatial computing is quickly becoming the foundation for how AR systems perceive, learn, and act in our 3D reality. From training ARs in video gaming-like environments to reshaping how robots learn through experience, our conversation today is going to unlock powerful insights about the future of mobility, simulation, and intelligent machines. So buckle up. It's going to be a mind-expanding journey. Aaron, I hope you can see me and you can hear me. Just to quickly tell you who Aaron Frank is, he's a researcher, writer, and consultant who spent over a decade working in Silicon Valley. He recently serves as a principal faculty at Singularity University, and his work there, he explores business, governance, and cultural impacts of a broad set of emerging technologies. In the past 10 years, he's built, deployed, and researched and written about technologies related to augmented and virtual reality and virtual environment technologies. His core area of focus in this domain really is around the spatial AR, where he helps government organizations and various corporate organizations really understand the space. So with that, let me welcome Aaron Frank. Thanks so much for being with us here today.
Hi, Mick. Yeah, good to see you. I can hear you. I can see you. Very happy to be here and looking forward to a nice discussion with you.
Amazing, Aaron. It's so interesting. Like the first time we met was in 2015 in South Africa, where you came with Singularity for that program, right?
Yeah, I think so. I think that was my first time. That was my first time coming.
And at that time, I remember, that was 10 years ago. And in those days, you were a big Pokemon Go player. Remember that?
Well, actually, I remember. So I think that was so Pokemon Go. I remember came out in 2016. So I think it was the year after my first visit. It was the next time, but that was kind of like the peak of that moment. That was quite an interesting time in augmented reality.
And that was it was so interesting because everyone thought the world had changed. There were going to be all these augmented reality experiences at that time, and I remember my wife was even in New York. They were, trying to collect those Pokemons at Columbus Square. It was like a craze. There were millions of people playing.
Yeah, I remember. There's that video where there was a flash mob in Central Park because some rare Pokemon had spawned there, and I actually remember talking to your wife about that. That I think she was either there or got caught in a similar experience.
Yeah, it was so interesting how people were so engaged in that immersive experience, and were traveling around the world, completely borderless, engaging in a shared experience. Like you were even, I remember you went to Monte Casino to get a Pokemon for your girlfriend at the time.
Yeah. So people like to dismiss Pokemon Go as this, kind of gimmicky kind of game thing. But for me, the thing that was always really fascinating is that it kind of points toward this deeper sort of impact of a technology like that, where if you think about it, this is just by layering the world with, in this case, augmented reality in the form of Pokemon, changes where people go, why they go there, what they do when they get there. And yeah, and like you're pointing out, Pokemon Go is interesting because it sort of motivated how people move through the world. It changed people's behaviors. Like I used to, walk a different route to my grocery store in my neighborhood because there would be, different gyms in the game. And yeah, the Monte Casino thing in South Africa was interesting because in Pokemon, there are like region specific Pokemon you can only catch in certain parts of the world, which on one sense actually created a lot of, not a lot, but there was, a noticeable shift in people's travel habits. People would, travel around the world, like no joke, to like go to different parts of the world just to catch Pokemon. And yeah, so my girlfriend, who was actually the reason I even got into it at all, basically when I told her I was going to South Africa, she said, okay, you have to get me, there's one you can only catch in Africa. And I was like desperately looking for it, and it did finally spawn at the Monte Casino, and I had to go like run over and get it. So yeah.
Yeah, and it's just like, I mean, if you think about now, we 10 years later, or 9 or 10 years later, and we've got this incredible explosion of AR technology. So I think, do you want to just explain to people what is spatial intelligence in AR,
Yeah.
and why is it critical, for our future of combining, embodying robots or robotics
Yeah.
with AR?
So I imagine, I know, this conversation we'll get into, we'll probably talk a lot about what's happening in robotics, what's happening in autonomous mobility. But I think in order to kind of build towards that, the question you're asking is a really good place to start. Because the thing that we should, remember, and it's actually, it seems like, such like an obvious idea, but there's this really big shift happening today in the way that we design our computing environments. So before I get to kind of the intelligence part of spatial intelligence, I think it's worth just briefly talking about what spatial computing as a concept is. And so really the term spatial computing, and there's a variety of different buzzwords that get used. The metaverse is one that gets talked about, augmented and virtual reality. But really at the core of all of these technologies is we're living in a moment where there's this big shift where we're reorienting our computing environments from these flat two-dimensional environments toward environments that are defined by this capacity to sort of account for three-dimensional space. And it's actually really interesting, like literally what we're doing right now, for those listening later as as like a podcast, you and I are standing in a virtual world that you guys have built. And this is a really good example of an environment that's defined by three-dimensional space. Like we have avatars, we're moving around, we have there's such a thing as like social distance. Like I'm looking out into the audience and people are kind of spread around, and an appropriate mimics the social behaviors and social dynamics of how we would behave in the real world. But again, the key point here is that spatial sort of three-dimensional space is at the core and the root of these kinds of computing environments. Now, the reason that matters for what's happening in the world of AI, and in particular AI as applied to like robotics, is that spatial intelligence. So we're becoming more and more familiar with these intelligence systems, things like ChatGPT, these generative AIs, these video generators, whatever it may be. Those systems are incredibly powerful and incredibly useful, but they're designed to process information that are essentially just symbols connected semantically, but have no connection to any kind of three-dimensional space. Now, if we want to build intelligent systems like robotics, for example, that navigate the physical real world, they have to develop an intelligence that's able to sort of process information that is rooted in an embodied sort of like physical world that is entirely about moving through three-dimensional space. And so what's happening today, and this is, I guess, going to be the core of what we'll get into and talk about, is that to build these kinds of spatially intelligent machines is that we're starting to use spatial computing environments. So that includes things like 3D simulations, video game environments, basically to allow these robots to get the training data to learn how to sort of, develop their intelligence in these spatial environments. And so it's about giving computers and giving machines the capacity to understand three-dimensional space. And this is, we're at the very beginnings of this world, in a sense, in some sense. And it's incredibly exciting, and there's so much happening, and it's really creating this like massive explosion in robotics innovation at the moment.
It's really, really incredible. So it's like allowing the AI to understand and navigate the 3D world like humans do. So it's like
Exactly.
having, so they understand the world in 3D like we do, pretty much.
Exactly. And we take for granted like how much of our intelligence, like human intelligence, like a significant amount of our processing of our nervous system and our brain activity is involved in processing, movement. There's, movement is really a core part of what we as, primates essentially are doing. And really, many animals that have central nervous systems, most things with central nervous systems evolved because it's about managing movement. And so our intelligence is deeply rooted in the concept of movement. It's deeply rooted in the physicality of the three-dimensional world. And really what we're seeing today is we're about to give that kind of intelligence to machines. And the reason for that is because we can now put these machines in these training environments and essentially these simulations.
And I mean, what sort of like environments or gaming environments or engines is essential to train these ARs? Like, what do we use to actually train these ARs? What for?
Yeah. So when we're talking about different kinds of robotic systems, there are different. I can kind of break down. There's like a taxonomy or different categories, and one, it really depends on what kind of robotic system we're talking about. It's probably worth mentioning. The term robot is an incredibly loaded concept. Like I think we have been conditioned from pop culture to when we hear the word robot, our mind immediately runs to like C3PO in Star Wars, or Rosie the robot in Jetsons, or pick your favorite term, whatever robot you like. But if we redefine in our minds what a robot really is, you can think of it essentially as just a computer that moves. And so when you think of it that way, it just opens up the landscape. So we're talking about driverless cars, we're talking about drones, we're talking about a variety of companies are launching, essentially farmerless tractors, these autonomous tractors on farms. We're talking about in warehouses, these, industrial machines, these like AMRs that are, at Amazon, they have these autonomous little, picker robots that go and like move around the warehouse to move boxes. So anything that moves essentially is like a robot. And so different types of robotics will use different kinds of simulation environments, but broadly, we could kind of distill. And then, okay, when it comes to programming robots, there's also a different kind. There's something called control, which is basically about like the physics of the robot, just like how does it like move an environment. And then there's something called planning, which is basically like allowing the robot to move and sort of like what are the tasks it does. And then the one that we could talk about is probably the really core to simulation is perception. So how does the robot actually see the world? And we could driverless cars are a good example. A car needs to be able to see the world, and so the environments that we're using to kind of train these intelligent systems are very similar to the kinds of game engines that power the video games that we're familiar with. So like the Unreal Engine, which the latest version, the Unreal Engine 5, which was first announced actually half a decade ago, in 2020. But that was an incredible improvement in the photorealism and the sort of like the graphics quality of these game engines. And so literally just like these kinds of game engines are starting to become so powerful that we can just place these perception algorithms inside the game engine, and it can teach itself. Like an example is Tesla. So Tesla, to build their full self-driving, one of the things they did is they built an entire replica of San Francisco in the Unreal Engine, and they basically just have their vehicles driving billions of miles basically, training the machine learning systems to learn to see the world. And there's a variety of reasons why there's, a great benefit to doing it in simulation rather than in the real world. But essentially, these kinds of game engines and simulations that, we're familiar with in, just regular gaming are again becoming so powerful that we can now use them in these more industrial use cases to train robots.
Amazing. So it's like the way we train ChatGPT using data. We train the robot using simulated worlds.
Exactly. Yeah. And the way to think of it, because people always wonder, is like the question I had, I wrote an article for Singularity Hub about a year ago, because I just didn't understand. I was like, how is it that a driverless car, you can just place it in a video game? Like a video game is not the real world. Like, how does a video game actually train the perception algorithm? And it has to do with the way these AIs actually see the world. Like, the thing that we tend to forget is that all of these neural networks that power, whether it's ChatGPT or a driverless car, is that it basically has to turn the data, whether it's, in the case of like ChatGPT's text, or a driverless car, it's like visual data, it's like, camera data. It turns all of that data into a number. And so in the case of a perception algorithm, it basically turns the colors of the pixels that it's capturing from, in most cases, camera data, or sometimes LiDAR data, into a number. And so just to kind of get a sense of that, imagine, a black, like, assume the world is in black and white. A perfectly sort of like black, like fully dark pixel would be assigned the number, I believe 0. And then a fully white pixel with no color in it would be, I think it goes up to 255. And then any variation of gray in between is, associated with some number. And then if it's in color, there's like literally millions of different colors that are associated with a number. And basically, what a perception algorithm is doing is it's seeing the world, and the world it sees is coming in as pixels. Like, when we look at pixels on a screen, that's the equivalent. And the color of the pixel gets associated to a number, and then the algorithm basically learns to sort of see the world through those numbers. And the point of why simulation is now possible is that the pixel quality, the photorealism, the graphics quality in a video game now is becoming almost indistinguishable from, the camera data coming from the real world. And so to the perception algorithm, it's still getting trained in the same way. And it's because of this photorealism that these algorithms can now train their perception algorithms. And that all comes down to this idea that the graphics are becoming incredibly photorealistic.
Unbelievable. Wow. Yeah. So it's like, I've been reading a lot about the new Tesla FSD. A lot of people are using it for very long trips and having these incredible experiences where they're like driving, from one state to another, without even having autonomously, and loving the experience. Like, once you've tried it, they say you just absolutely love it, because you feel, totally safe and in this vehicle that knows how to move you from one place to the next, and you've got freed up your time, totally given you a new behavior. Oh,
yeah, I think that's a great example of the kinds of implications that will start to happen as a result of, putting autonomy, again, this is the spatial intelligence that you referred to earlier. Once you embed a machine, in this case, a Tesla as a car, as a machine, with this kind of spatial intelligence, it unlocks a whole new set of behaviors and how we relate to these machines. And there are so many ways that we can imagine how this kind of autonomy is going to transform, both our, professional lives, our personal lives. So yeah, it's really crazy what's happening. And it's not just in cars, like, it's happening in drones. It's happening in, there's a startup in San Francisco that I'm tracking that's basically, think of it like a little lawn care Roomba. It'll cut your grass, like a little robot that will just go and cut your grass. And that, there have been grass cutting, systems for a while. The key difference, and this is something that we should definitely talk about, is that, like, the reason that's possible is that because we can train robots in simulation, it allows the developers of the robot to basically allow the machine to teach itself rather than what used to be the case where you had to explicitly program, like developers, roboticists, basically developing robots up until like this. We're talking like within the last like 18 months to 2 years that this shift has happened. But up until maybe 2 years ago, being a roboticist meant basically defining the set of tasks that you want the robot to do, and then explicitly writing the code to like program, basically giving it the rules for how to do those tasks. And then that's, so we have, if you want to make a robot that cuts grass, you have to have a very consistent, terrain. You program the rules for how to cut that grass, and then the robot can do it. But now what's happening, this big shift, and the reason simulation is such a big deal, is you can put the robot into essentially a video game. And because it's, a video game where it can fail, it's not going to, harm anyone. It's not going to, blow up your lab. You can have the robot learn through trial and error, which is essentially unlocking this whole, world of machine learning that's, been completely defining the world of AI for the last decade. This is reinforcement learning, where these robots can learn through trial and error, through like millions of, trial and error. And that has never been possible really before. Again, this is like, that's how new this is because of how good these game engines are getting. This is something we're talking about that's only in the last couple of years. And so now, you're going to see this explosion of different kinds of, now we have Teslas that can drive people across whatever. There's this, if I don't want to cut my grass, I can, put this little lawn care Roomba that, it doesn't care if it's never seen that particular lawn before. It's been trained, in simulation, that it just knows how to like figure out the boundaries of what is the lawn, what's not the lawn. So we're going to see just like a Cambrian explosion of new kinds of intelligent machines. And again, it's so like, this is one of the most exciting like shifts I've seen in my career. And it's just in the last like couple years.
No, it's amazing because I think it totally lowers the barrier for entry. You've got startups, smaller teams. There's a lot less coding.
Totally.
There's more training environments. It really democratizes robotics and embodied AI innovation, which is phenomenal.
Absolutely.
And
yeah,
like I remember when I was 4 years old. When I was 4 years old, I actually had a growing pain, so I was in hospital for 3 months with my legs up, and my mom bought me a little robot. And I had a little recorder, so I could pull the recorder down and record like a minute-long message, and then drive the robot to the nurses and get the robot to ask for a glass of water. That was literally,
wow,
it was 40 years ago.
You were ahead of your time.
So, I've always had this love, and now I can't wait to have. We've got actually a robot graveyard at our offices for all the different robots we've bought over the years, from the beams and the Jibos
you need to revive them. Bring them back to life.
We need to revive it. Now we've got a dog. There's actually a dog in our office, Murphy, the robot dog, which is quite a unitary robot. And we are going to bring a bunch of other robots to the Singularity Summit this year.
I was gonna say the Unitree. We just had. I just saw a Unitree for the first time. We just had a program in California, and they had one walking around. Pretty crazy.
The G1.
What's that?
The G1. Was it the humanoid one?
Yeah, exactly.
Yeah, awesome. And I mean, like, how do you think this is going to change? How is embodied AIs and autonomous vehicles and humanoids going to reshape industries and infrastructure? Because I think, even there's some people in the audience that have their own car dealerships, as an example. How's this going to, shift and change all of these different industries and the infrastructure to evolve it?
Yeah, this is such a good question, and this is probably this is kind of the core of what I'm currently thinking a lot about, and doing a lot of research and doing a lot of interviews and talking to people in different industries. And there's a few thoughts I have. Like a couple caveats at the beginning is that what makes this a tough question is it really depends on so many other variables that have nothing to do with the actual technology of the embodied AI. Like, basically the premise that I'm coming from is we are living at a moment, this, radical inflection point with the development of robotics. It's still kind of like the early beginnings of this inflection point, but this shift from, a world of control where you have to explicitly program to a world of training. Like, the big implication of that, as you just pointed out, is that it democratizes access. So we're going to see this explosion in innovation, small teams trying wacky experiments that, we've never seen before. And so what does this mean is like basically the question. And it really so the things it depends on: one, it depends what industry we're talking about. Two, I think it will also really depend on what region. Like, I think this conversation will look very different in, say, like Japan and Korea, which is already, one of the most automated economies in the world. And, they've been sort of embedding autonomous systems into their, infrastructure for many years. Will look very different than in, say, like, in Africa or in South America. And so, okay, so that's one thing. But, if I focus, let's take like industrial warehousing and like supply chain. There's at least, and a lot of my research looks at, I'm in the United States. So there's a company called Boston Dynamics, which is, one of the, well-known robotics companies. And they are really on the cutting edge of building these kinds of like autonomous systems. And so they have a machine called Atlas, which they're starting to deploy in sort of like industrial manufacturing, like warehousing type environments. They also have a machine called Stretch, which is super interesting to me because it already sort of being deployed in sort of logistics, like warehousing environments. And so I'll take the Stretch example. So this is an autonomous like mobile robot that is basically, think of it like a giant crane with suction cups, and it can just move really heavy boxes. And so, before Stretch, if like a tractor trailer comes in with, a bunch of equipment, humans, workers used to have to go in, take the boxes, put them on, sort of create the beginning stages of the, the operations to get the stuff to where it needs to be. That's a really kind of like back-breaking job for people to have to like bend down, pick up boxes. So now this machine is basically capable of just going into the truck, grabbing the boxes, putting it on the conveyor belt. What's interesting is it hasn't, at this point, from what I've seen, displaced any warehouse employment. What it's done is it's relocated and reallocated where the human workers in these environments need to go. So basically, the point I'm trying to make is, I think there's definitely a question around, the displacement to labor markets or the impact to jobs. What makes it really challenging is, when you embed autonomous systems into a system, some kind of operational system, let's say in a warehouse, it's not just about taking the existing processes and then just like taping some autonomous systems on top of it, or, replacing humans with robots. It seems to be that it requires like a fundamental redesign almost from the ground up of how we sort of like build these systems that sort of like integrate this idea of autonomy almost from the beginning. And that takes time. That is challenging. That is a great example where, when it comes to innovation, the technology is very often like the easiest part of the process. There's actually this whole kind of like change management system. But to kind of get back to the core of your question, like, what does this mean for like our systems? Is we are about to enter into a world, and it's not just going to happen overnight just because we have these new technologies. It will take time to redesign our infrastructure. But like you're describing, like a world where people can get in a Tesla and drive, halfway across the country without touching their car. In San Francisco, there's a company called Zoox, which is about to launch a driverless car that is completely designed in a different way of any car I've ever seen. It basically, if anyone's been to London, those taxis where you sit facing each other in the back. It's this, except in the Zoox case, there won't be like a steering wheel. It'll be like a little, mobile like bus for, maybe 4 or 5 people with, like just the design of the world is going to look very different once we start embedding these systems. And it will take time to kind of redesign, with, drone delivery in mind, or with, autonomous robots in a warehouse setting that, displaces where what once required humans to lift heavy boxes no longer does. So imagining what that world will look like is quite challenging to kind of put together the implications of what this means for, our labor markets, for, our road infrastructure. All of that is very challenging to do. But ultimately, there are big changes coming, and we will, in some sense, have to redesign almost from the ground up in many ways how we design the world around us.
No, it's going to totally disrupt the way we live, the way society works, how we, how we operate in our businesses, in corporates, and in our personal lives. I mean, everything's going to be much faster, more efficient, decentralized, hopefully, so that it's
Ideally.
more, hopefully, less power in the hands of the few. We had Peter Zing on 2 weeks ago, and he was talking about these big platforms that are going to really operate the world. He believes that when the big players are going to sort of be running these AI platforms that are going to people are going to use throughout. But because AI scales with centralized data, but blockchain works with decentralization. So the real magic's going to come when the two meet, and we create trust. Using the AI and the decentralization and security for people.
For sure, yeah. Like
So,
how we design governance structures around the data will definitely matter. But yeah, sorry, it sounds like I cut you off.
No, all good. I was just about to say that if anyone, we are going to take some questions. We've got about 10 minutes or so left. So if anyone wants to ask any questions, you can jump on those blue circles and ask away, or you can just write in the chat if you have any questions for Aaron. Also just something to point out is that a lot of guys like Elon Musk and Brett Alcock from Figure Robotics, they're predicting like millions of these robots running around in the next 5 years or so. So it's not a far away timeline. We're going to have millions of robots running around our physical world, interacting with us in so many different ways. What does it mean for humans?
Well, it's interesting that when they make these claims, there's a big discussion happening in sort of, and an interesting question is, well, like, why humanoid robots? Because like earlier we talked about how the term robot, we should open up the territory of what that word associates with drones and cars and whatever. But there is this huge surge today, and there's like this huge explosion in the number of companies building, in particular, humanoid robots. Like Tesla, wants their Optimus. Figure Robotics. There's the Norwegian company 1X. There's Unitree, of course. There's like tons and tons of these. And so part of the reason for that is one is like we live in a world, like our world is kind of designed with human activity in mind. So building a humanoid robot is far more likely to be able to kind of like easily integrate with the world that we have sort of already constructed. The second reason, and this was shared by I had a conversation with, I think Hod Lipson, an AI expert at Singularity. Maybe he's joined you in South Africa in the past as well. But he pointed out that a lot of the way that these robots are learning is by sort of imitation. So these machine learning algorithms that can watch videos of human activity. If you think about what like the largest data set of videos is, that we have a lot of data for humans doing activities, and so building a system that's sort of modeled after the same design as what this training data would allow for. So there's a few reasons why humanoid robots in particular are getting so much attention. I don't think that will be the only type of machine that we should focus on as seeing a lot of this innovation. But you're exactly right to point out that there's a lot of these claims that in the next few years we're going to see millions of these kinds of humanoid machines, either in our homes, in our I don't know about in the home in 5 years, but definitely in our sort of manufacturing facilities, in our industrial settings. We're going to see a huge explosion in the number of humanoid machines out in the world.
Yeah, like I know there's the surrogate X Prize is also something quite interesting where you can actually embody a robot that's in another country and go and explore that country as just having the robot body, but it's got you're the vision, almost like the beam robot. Remember those beams we used to have?
Exactly.
There was a big with the poles, and I would drive it around. We had one in Joburg, and if I was overseas, I would bring my beam and join meetings. But now you're going to have fully functional, multi-dimensional robots that you can embody. And then what about the idea of actually cloning ourselves? So like making I've got an AI clone of myself now in the digital form, but to have a clone of yourself in the physical form and let that clone go do your work or do meetings. And
Yeah, I mean, no reason why you wouldn't be able to have, a machine kind of modeled after your physiology and your, whatever you want to sort of capture and replicate in some kind of, avatar embodied robot form, and then you could send it, like your beam example, anywhere in the world. I also think in the future it's very likely that, we'll probably be getting surgery performed by someone who's actually, halfway across the world. If you know that Intuitive Surgical is a company that does sort of remote, machine assisted, like robotically controlled, very high precision, surgery. So like I totally imagine a future where, I go to my local clinic to get a surgery, but the actual physician doing the surgery might be in, like Korea or something, or in, Europe or in Africa or wherever. Even though you have, and so as like you as a physician, you're going to the office, you're doing your work, but you're doing it, you might be performing surgeries all over the planet, even though you're, sitting at your office. Like that's the kind of telepresence, teleoperated systems that will be possible, given, what you're describing.
yeah, it's really exciting. It's going to be massive change in the next couple of years. Does anyone want to ask any questions? We do have a few more minutes. You can just unmute yourself or write in the chat if anyone's got some questions. Finally, I'm here. So excited. Looking forward to this. Toots. Awesome. Here we go. France. Have the regulations around liability, as an example, caught up to the ability of robotics?
Yeah, that's a great question. I unfortunately am not really, probably the person to ask about this. This is I will say, like, so my background, we didn't really talk about like what my core like research background is. I For the last like 10 years or so, I've been deeply focused on the world of mixed reality, augmented and virtual environments. Um, I am very new to the world of robotics. I do not identify as a robotics expert. The reason I am sort of like so sort of fixated on this topic at the moment is it's like all of a sudden, just in the last, like 18 months or so, is that the robotics industry are becoming like big customers of the kinds of tools and technologies that I've been researching and studying for, for the last 10 years. So I'm new to robotics. I'm fascinated by what I'm learning. It's like when I talk to someone like Hod Lipson, it's always really interesting because he's, an AI and robotics expert. And he's always telling me the latest of what he's seeing. And then he comes to me and I'll tell him, NVIDIA just released this new, simulation tool and it can do this, this, and this. And he can immediately tell me, he's like, oh, well, that's amazing because I can use that for this, this, and this. And so it's this really interesting intersection. When it comes to the regulatory environment, I think that, my sense is that broadly with most emerging technologies is that they are very slow to adapt. They are very slow to absorb into their worldviews the kind of the implications of a lot of these new environments. I like, for example, like who's liable in an autonomous collision of some kind. I don't know the answer to that currently. So it's a really good question, and I share the same.
Awesome. Yeah, I think the regulations are, it's moving too quick to regulate. Even the drone industry, as an example, if you look at how when drones first came out, it was the wild west of drones, and now it's pretty regulated. You got to have licenses and be a licensed drone pilot. So I don't know about Zipline. Do you know about Zipline as a robotics company? I think what they're doing is phenomenal.
Yeah,
in terms of drone delivery.
100%. Yeah, and I was actually, so Zipline is a great example of. I was actually I wasn't gonna show. I wasn't gonna do like a screen share and show. The one thing if I did do a screen share, I would show. Zipline is a great example because for anyone that's not familiar, they do drone delivery. They actually just launched in Mesquite, Texas. They have a whole drone port where they just have drones like delivering things. They're in Africa delivering things like anti-venom for like snake bites and vaccines. They've delivered millions of vaccines in Rwanda, and they operate in Ghana. they do a lot of their tests. They design their drones in simulation. So like how to make sure that the drone can fly in inclement weather, in stormy conditions, like how to do takeoff, how to like they and I have a video of some of the simulation tools that they use. So Zipline's a great example of what's coming as a result of these kinds of developments.
Yeah, it's phenomenal. We actually saw that with all those drone ports recently. It's just phenomenal what they're doing. We've got a
Yeah.
question from Brendan here.
Yeah, it's a
He
great
says,
question.
thanks for the informative chat. Is the push towards humanoid robotics more a psychological problem, something that we expect to see, or a physiological problem in that the robot needs to exist in the same space as humans, and humans designed our world around our physiology?
Yeah,
Great question, Brennan.
great question. And so there's two things to kind of tease out from this. So the first is Brennan's right to point out that humans kind of our world has been designed with humans in mind. And so humanoid robots need to be able to, and the reason why there's such an opportunity with humanoid robots is because they're shaped in the same way, they have the same kind of like mobility structure, is that type of design of a robot is the most likely to be able to sort of like integrate into the existing infrastructure, as Brennan describes that our world's been designed with human physiology in mind. The other thing that's important to call out from what he's described here is that one of the biggest challenges with all of these autonomous machines is that they need to be able to operate safely in environments where there are already humans, as Brendan mentions, that they need to exist in the same space as humans. It's exactly right. And so that is actually one of the biggest benefits of these simulation tools, which we didn't really talk about, is that you need to be able to train these systems to be able to navigate environments, to understand things that is very hard and difficult to get training data. So for example, and we'll take the car, is you want to make sure that your car doesn't, if like a child runs into the street chasing after a ball, you need to be able to give the car like the training data to understand like what that looks like as a scenario. But where do you get that training data? You're not going to have like, you're not going to volunteer your child to go like practice being the test child to like run in front of a driverless car, right? But you can get that in simulation, and this is actually exactly one of the key use cases for simulation. So I went to NVIDIA last year, and I talked to them a lot about the way that their customers are actually using these simulation environments. And overwhelmingly, one of the most consistent things they say is to provide synthetic training data for scenarios that involve human safety, to make sure that, let's say, a drone at IKEA. So IKEA, just for example, they launched last year these inventory drones in their distribution center. So there are drones flying around in their distribution centers doing inventory with human workers also in the same space. So to make sure that those drones know how to navigate in the same space where there are humans in a safe way, that a drone would recognize if a human has been injured and it doesn't want to cause any additional problems. That training data very often now comes from simulation, because there's no other way to get these kinds of training scenarios to teach the robot. And so that's a huge benefit of simulation. And so, as Brendan mentions, it's really about making sure that these machines can operate safely in environments where humans already exist. So that's a big part of it.
So interesting. And I think France also, that also maybe can relate to the regulations lagging. I think that by using AR, we might see regulation speed up, because if we use AR to help us work out the right governance models and the right ways things should be, we could possibly simulate different types of governance models to see what will work. There's a question from student at UNISA. Thanks for joining. Regulatory authorities seems to be lagging behind. It could be partly due to rigorous systems which make it a bit challenging to anticipate change, maybe. And then Paul says, super awesome conversation today. Thanks, Aaron. Thanks, and Paul. So we will take one more question if anyone's got any other questions for Aaron. Aaron, we just want to say thank you so much for your time. We really appreciate it. We know that you got a plane to catch to Europe now, and it is probably like 6 or 7 in the morning for you. So thanks so much for being here. And just where can people reach out to you if anyone wants to follow you or follow your progress? I know you write a bunch of articles.
Yeah, there's a couple places. One, I'm very happy to connect on LinkedIn. Any of my writing that I'm like happy with or proud of, I usually post on LinkedIn. So that's a good place to follow. Most of my writing and most of my sort of like repository portfolio of work is on Singularity Hub. So I have an author page, Singularity Hub, Aaron Frank, and then on Twitter. I'm also on Twitter, or X now. So, but LinkedIn is probably the best.
Awesome. Thanks so much. And make sure if this will be edited and put on a YouTube, so make sure to go check it out next week on podcasts and on YouTube, Exponential Africa. And if anyone hasn't, I know a lot of people didn't get a chance to do the treasure hunt. Please go do that. We'll be giving away a $500 prize for the winner there. And yeah, have a great day. If everyone can give a big jumping applause for Aaron to jump, you just press spacebar. Let's see some applause, please. Thank you so much, everybody. Yay.